so fast. Can we trust this timer? Is she going to, I get 5 minutes into it and then she gives me this. I don't get it. I'm going to watch you this time, okay? I'm going to time you here. I'm going to time me, okay? Okay, here we go. This is the neutron absorption hypothesis, and I got into this, let me back up a little bit. When the statistical analysis was published in the British journal Nature in 1989, I read it maybe a year in the library, and as I was finished reading it, I had a real sinking feeling, how can this possibly be true? Because there's so much evidence that it really is the authentic burial cloth of Jesus. How could it be dated to the Middle Ages? And then, at that point in my life, I had 19 years experience in calculating neutron distributions in nuclear reactors. So I reasoned out, just looking at the data, I thought I realized what the explanation was. But at that point in my life, this would be about 1990, I didn't have the time, I didn't have the computer fast enough, and I didn't have the computer code that I needed to model the problem. And all three of those didn't come together until about 4 years ago, which is when I started modeling this problem with my nuclear analysis computer codes. MCNP is the acronym, Monte Carlo neutron particle, or N particle. And so at that point, I did about 400 or 500 calculations running in time from about 6 to 13 hours each, running 4 at a time on my quad core. And then had to choose one case and then report it at the Shroud conference in St. Louis in 2014 out of all the 400 cases that I ran, because the problem was that there's so many different uncertainties that you have to run enough calculations in order to bracket all of the uncertainties. So you're not really sure what energy the radiation is coming off from. You're not entirely sure how the neutrons are being emitted, whether homogeneously, isotropically, or with direction. And you're not sure about the distribution of emission within the body, et cetera, et cetera. So you have to just bracket all of those uncertainties in order to determine what effect that they have on everything. So let's get into this. Now, here's a summary of the evidence, where we're coming into this. The Shroud is not from the Middle Ages. Now, I'm not going to go back and review all the reasons for this. I'm just going to state them. This is the conclusions that we've come to. Shroud is not from the Middle Ages. Shroud cannot be a human production. Image was produced by the body. The other dating methods are consistent with the Shroud being from the time of Jesus. Carbon dating is an outlier. That is, it disagrees with the other dating methods. And then the significant question is, how could the carbon dating be so wrong? So the next one. This is just a little bit of a background. Every atom, a little bit of theory here, every atom, it's like a solar system. The heavy mass is at the center, made up of neutrons and protons, and then the electrons are like planets that go around the sun, except in this case, you have multiple electrons in each orbit. The inner orbit can contain up to 2 electrons. The outer orbit of the carbon atom can contain up to 8, but in the case of carbon, it has 4. But there are 6 protons to exactly balance the 6 electrons. So the electrons are negatively charged, the protons are positively charged, so the atom overall ends up as neutral charged, okay? But you can have different number of neutrons, so that 6 neutrons plus 6 protons would be carbon 12. 6 protons plus 7 neutrons would be carbon 13. And 6 protons plus 8 neutrons, 6 protons plus 8 neutrons would be carbon 14. And so of all the carbon atoms, about 1%, 99% will be carbon 12, 1% about carbon 13, and carbon 14 is way down there, almost insignificant, very small fraction, and hard to measure. Yet that's what carbon 14 dating is based on, a very small fraction of the carbon atoms. Okay, and we went over this before. The amount of carbon in a plant is constant until it dies, and then it will go on this decay curve, so that carbon dating is done. 92% was measured, and they come over to this curve, and they said it was 700 years old. So the average of the 3 labs, the raw data was 1260, supposedly plus or minus 31. They gave a corrected range of 1260 to 1390, just based on the data in Damon. But a middle age date must be wrong. It really must be wrong. It's not possible to make an image like is on the Shroud in the Middle Ages. The technology did not exist. It doesn't exist today. So they could not have made it in any previous era or today. Even with all of our computer and laser technology, you couldn't make that image. The Shroud is not a fake or forgery from the Middle Ages, the same reason. It contradicts history. History proves that the Shroud is very early, let me just say it that way. And it contradicts all the other dating methods. So that the first explanation for the carbon-14 date, we'll just go through the sequence here. And this, was the first explanation for the possibility of the carbon-14 dating being off was given in the same issue of Nature, British journal Nature, peer-reviewed, highly reliable journal, and it said in one of the letters, the Shroud irradiated with neutrons was the title by Thomas J. Phillips of the High Energy Physics Laboratory, Harvard University, said, the body, quote, may also have radiated neutrons which would have irradiated the Shroud and changed some of the nuclei to different isotopes by neutron capture. In particular, some carbon-14 could have been generated, which would then make carbon-14 dating certainly questionable. Okay? So that's the very first explanation. Other explanations, contamination of the sample area due to talc, wax, oils, etc. These would be removed in sample cleaning. I think that's a true statement just based upon what Damon says. They did progressive cleaning of the Shroud samples, testing it for the carbon-14 date after each cleaning. And what they recognized, what they stated, was that additional cleaning didn't change the carbon-14 date, so that therefore any contamination such as this, they concluded, would have been cleaned off in the first level of cleaning. And some of this cleaning was severe, where they might end up with only 15 or 25% of the original weight of linen left. It was very severe cleaning. Next one would be contamination due to absorption of carbon during the fires. This would also be cleaned off because any absorption of the carbon during the fires would be on the outside of the fibers. That's what I understand. I'm not an expert on this, but I just read what other people say. But that also would be cleaned off, and it would be too small to explain the date shift. And so then, in the history of Shroud research, they've gone through each of these one by one and investigated, all except for the first one. They've investigated each one, and it's kind of fallen by the wayside with further analysis. And so the next one to come up in this sequence of investigation was that there was an isotopic change in the carbon-14 content due to the fires, isotopic fractionization, it was called. But again, it would be too small to explain the date shift, apparently. And then the next option was bioplastic film due to bacteria growth. And again, it was under further investigation. It was just not a significant amount of bioplastic film on the bacteria. It was more a problem of focusing the microscope than bioplastic film on the fibers. But this one fell by the wayside. And then the most common explanation that you see almost universally here in videos on YouTube and videos that are produced is the invisible patch or reweave theory. Now, a textile expert, and the debate goes back and forth. With Joe Marino, one of our people on our organizing committee, there's a difference of opinion here, and on another issue between Mark Antonacci and myself. So that I was told by a wise person that this is a very interesting business because your very best friends you will disagree with. Which is fine, because what we're seeking is the truth. And we have to try and consider things objectively and be willing to back off of positions when the evidence supports doing so. Okay? And so anyway, the point here is that, for example, textile expert Fleury Lemberg, I guess which is regarded as one of the leading textile experts in the world, said there is no doubt that the shroud does not contain any reweaving. Reweaving in the literal sense, that's of invisible reweaving, in the literal sense, does not exist. There's no such thing. Not really. And so, let me move on. Now, the conclusion regarding the dating. The question is, how could the carbon-14 dating in 1980 be so wrong? Based upon my coin in my pocket. It is very wrong. How could it be so wrong when the equipment is so accurate? So the neutron absorption hypothesis, first proposed by Thomas J. Phillips in 1988, is the concept, in my opinion, that is most consistent with the four things that we know about carbon dating and the shroud. So what is it that we know about carbon dating and the shroud? We know that the uncorrected raw value is 1260. We know that the slope across the values from the three different laboratories is about 36 to 38 years per centimeter. Now that's a lot. Just think, there's 2.5 centimeters in an inch. So in 1 inch, if you move the sample point up 1 inch, you change the date by about 93 years. If you move the sample point up 13 inches, that would be the difference between 34 AD and 1260. Wow. I mean, so this is a huge slope that we're seeing here. The range of the values that were calculated, measured, were from 1155 to 1376. And the sudarium dated to 700 AD. The sudarium is this face cloth that's believed to be authentic and is now in Oviedo, Spain. And that's been discussed already. So I think those are the four things. Now, this is on the assumption that the sudarium Oviedo is the authentic face cloth of Jesus. I think that's correct. But these would be the four different things that we know about carbon-14 dating. Now, the big picture. Where are we going with this? We've concluded that there's many different reasons to believe that the image that we now see on the cloth is the result of a burst of radiation from within the body. Now, that must be the case in my reasoning, because in order to, we'll get into this, in order to form that image, just think through with me on that. We need three things to form an image. Any image that you see on a photograph, on your computer monitor, on the television, even looking out in front of you. What is it that communicates your image to my mind? What is it? Do you know what it is? It's reflected light, photons of light that reflect off of you. They go in all different directions, some of them to my eyes, so that the color of you is communicated to my eyes by the energy of the photons that are reflecting off of you. The shade, light versus dark, is communicated to my eyes by the intensity of those photons, more or less. More photons would be light, fewer photons would be dark. Now, when a photon reflects off of her elbow, goes through the lens of my eye, it hits a certain cone or rod on the back of my eye, thus indicating the position. So the angle of the photon going through the lens of my eye determines the position of everything in that image. So that photons are almost ideally suited to communicate information. And most of the information that's communicated in our environment is by photons, because we see continually. And all of that information is communicated to us by photons of light, reflected photons. Isn't that amazing? Bet you never thought of that. This is true. So what we're talking about here is that there was a burst of radiation from the body that caused the image on the body, and if there's a burst of radiation emitted from within the body to form that image, then what components are there in the body? Well, the body's made up of atoms. The atoms are made of protons, neutrons, and electrons. So let's consider those different components. For example, neutrons. How many neutrons are there in the average human body? 2 times 10 to the 28th. 2 followed by 28 zeros. That's how many neutrons in a 170-pound person there would be, based upon the composition of the different elements. So that there are plenty of neutrons in the body. So that if there's a burst of radiation, from the body. Those neutrons could either come from the body or come by the process of that body disappearing, because that's what the historical documents report to us, that the body disappeared. Okay? So, if the neutrons were released from Jesus' body in the tomb, then some of them would have been absorbed in nitrogen-14 in the shroud to produce new carbon-14 atoms. The idea here is that burst of radiation that formed the image, in my hypothesis here, I tried it, it seems to work. That's how science works. You gather the data together, you come up with an hypothesis that explains all the data, you then make predictions of that that fit your hypothesis for testing. If those predictions turn out to be true, then your hypothesis is more likely to be true. So that's what we're doing here. So that the burst of radiation occurs that forms the image, probably by charged particles such as protons, possibly electrons, and possibly ultraviolet light. But the neutrons then would flow out, would not cause the image on the shroud, but they'd flow out, bounce around in the limestone of the tomb, and in general they take a characteristic shape which can be calculated using our neutron computer calculations that Kevin and I have run for many, many years. And so that's what we've done. So that in that distribution, those neutrons would, as they bounce around, they'd be coming through the shroud, and there is a trace amount of nitrogen in the shroud, including nitrogen-14. When nitrogen-14 absorbs a neutron, this is a well-known example here. Nitrogen-14 absorbs a neutron. It goes to carbon-14 plus a proton. Now, we don't care about the proton, but the point here is that this is a means of creating new carbon-14 atoms in the linen. This is a well-known reaction, but carbon-14 dating is based on the measurement of carbon-14 in the linen. So that if we're producing new carbon-14 in the linen, what does that do to the measurement value that results in the date? It changes it. And because you're producing additional carbon-14, it moves the date into the future relative to the correct date. Okay, so what I'm saying here is that the correct date would be consistent with the time of Jesus, 34 AD, but the production of new carbon-14 atoms on the cloth shifted the date forward to give a date at that point near the feet, lower left-hand corner, of about 1260, though there was a slope on it for the three different laboratories. So that this is a way of shifting the date. Now, how much does a carbon-14 have to change? Only 16%. If this reaction changed the amount of carbon-14 in the cloth by 16%, it would shift the date from 34 AD to 1260. Well, how many neutrons would be needed for that? It's about 2 times 10 to the 18th neutrons released from the body using this mechanism, would shift the carbon-14 date from 34 AD to 1260 in the lower left-hand corner near the feet. Well, what is 2 times 10 to the 18th compared to the number of neutrons that are in the body, 2 times 10 to the 28th? Well, it's 1 in 10 billion. So in other words, if one neutron in 10 billion were released into the environment in the tomb, it would shift the carbon date. It would create 16% new carbon-14 at that location on the shroud and shift it forward from 34 AD to 1260 AD. Well, how many cells would contain 2 times 10 to the 18th neutrons? 3. So if you take 3 cells from your body, take the neutrons out, release them into the tomb, you would change the carbon-14 date from at that location from 34 AD to 1260 AD. Are you all following me? Okay. So the result here that we get, this is the MCNP is a code that Kevin and I were using for, 12, 13 years doing our criticality safety calculations. If 2 times 10 to the 18th thermal neutrons, and they could be any energy, but this was the case that I chose to present in St. Louis. 2 times 10 to the 18th thermal neutrons were released from Jesus' body in the tomb, it would increase the average carbon-14 content in the Shroud samples by 16%. This would shift the carbon-14 date for the Shroud samples from 30 or 34 AD, whichever you prefer, to about 1260 AD. So, MCNP is Monte Carlo neutron particle, or N particle, developed over the past 6 decades by the Los Alamos National Laboratory, tested and confirmed by comparison of calculations with experiments in nuclear facilities. It's used worldwide, and most important of all, it's validated by our government. That settles it. Now, yeah, I'm a believer. Yeah, there you go. I'm a believer. Okay. Okay. So this is how we modeled it. This is the limestone. This is my best 3D diagram of how I modeled the limestone tomb as it would have been designed in Jerusalem in the 1st century. With the pit area here, there's a left bench, there's a right bench, there's a back bench. Remember John bent down. He looked in from well back, because he wouldn't want to block the light at the door. From well back, he could see the burial cloths. That indicates that it was on the back bench. The face cloth of Jesus would probably be placed right about there if the man removing it, folding it up, would put it right about there. Okay. So this is a top view of the body as I modeled, just very simplistic geometrical figures. The cloth is just like that. This is just a top view with the limestone around. This is just a small piece of the limestone that's showing. Side view would be this. This would be the body with the feet down here. The sample was taken right down here. Okay, and so this is the distribution. If we have the head to the right, feet to the left, the neutron distribution peaks up kind of over the center of the body mass and then falls off again. That's why we see this distribution right here. The head would be down here. The feet would be down here. The second point is where they took the sample from. Okay, that's the neutron distribution in the body. I can take that, neutrons per square centimeter, and this is the X value along the midline of the body underneath the back. So this would be on the dorsal side. So I can take that neutron distribution and then calculate how that is absorbed in nitrogen-14, gets a very similar shape. And based on that, I can calculate the effect that it has on the carbon-14 date. So that the second point, right there, I've normalized the whole calculation to the only value that I knew based upon the experiments from the 3 laboratories. And that, which is 1260. So that second point is normalized to 1260. But on the backbone, if we could get a sample from underneath the center of the body mass, according to this theory, it should date to 8,500 AD. 6,500 years into the future. How is that possible? It's because the concentration of carbon-14 in the sample would be far more than what they'd expect due to neutron absorption. So that there's a tremendous distribution of dates that I'm predicting across that cloth. Okay, and so that at this point, what I'm saying is that at this point, bam, when the burst of radiation occurs, in a very small fraction of a second, you would have 16% on the average new carbon-14 produced, and because those 3 different samples were actually 3 different locations, though right next to each other, but the slope on the distribution of neutrons is very high, so that there would be 15.2% in one, 16.2, and 16.7. The 3 different samples would actually have different amounts of carbon-14 produced in them, which is, when they decay down, they measure 92%. They come across not to this slope. That slope is false. Now, they have to come across to this slope, which is what gives the 3 different values from the 3 different laboratories. So the true value of carbon-14 in each of the 3 samples was different due to different amounts of neutron absorption. Their equipment measured the correct values of carbon-14 in the samples. Their equipment worked right. Their procedures were correct. Nobody made any mistake. except in the statistical analysis, not recognizing that there was a systematic problem affecting all of the measurement values. So it just wasn't done thoroughly enough. And that's due to the shape of the neutron. So the three different values that were measured by the three different laboratories, they were different because of the shape of the neutron distribution in the tomb. MCNP nuclear, okay, we did that already. So in my printout, I have the right side bench, I have the left side bench. This is how I'm going to display the data. I'm explaining this. This part here is below the body. Then at this line, I do a 90-degree turn. This comes up on the right side. This is another 90-degree turn. And so this is above the body. This is another 90-degree turn. This comes down on the left side of the body. So that when I display the data, it comes out this way, so that the 1260 value is down near the feet, right about there, okay? And so that here underneath the backbone at the center of the body mass is 850, 8,500 AD. Now, the interesting thing here is how fast these values fall off as you come away from the back bench. And this is all data that's calculated by the nuclear analysis computer code that's been validated by the Nuclear Regulatory Commission. So that the date that we obtain for a reasonable location for the Sudarium of Oviedo, which would, if you work at the front of the pit area, you reach over, you take the head cloth off the body, you probably just lay it right about there on the side bench. You wouldn't, rather than putting it back there or something, you'd probably just lay it there, not thinking about it. Well, that is just exactly, it's very close. These are the values that are within 50 years of the experimental value for the Sudarium of Oviedo, which was 700 AD. So that this methodology also predicts, it is consistent with a reasonable reason why the Sudarium of Oviedo dates to 700 AD. I think I've shown you this before, how this line right here, let me go back up here, that's the same as this line right there. That's where the slope comes from. That's predicted by the computer analysis. Let me move forward. That's this line. Don't you think this line has a better agreement with the data than that line? Seems obvious, doesn't it? So, what we have here, I have a display here, a table showing if you wanted to break down the samples both in the X and Y direction finer. So that here's the Tucson sample that went to Tucson. So when they subsampled it, we're not sure how they subsampled. They never told us. They maybe never recorded it. But there's the Tucson A1 sample, there's Zurich, there's Oxford. So if I apply the same slope that's in this direction to this direction, and that's just making an assumption because these calculations are very long, and I've been busy doing other things. And I know, I'm watching her. She's right. It's 5 minutes left. But I'm going to use them, okay? Okay, so what we say here is that under those assumptions, this would be a reasonable estimate of what we ought to expect the measurements to turn out. And whoops, let's see if we can, okay, I didn't put in the other one. But in reality, this distribution is in good agreement with what they actually measured. Now, the other alternative here is that if we attempt the explanation of an invisible reweave, we can get a 1260 date on the average. That's easy. Just that you'd have part of this being old material and part of it being new material. The new material might be 1550 or something. Choose your value, whatever you want. Then to get a slope across this, because that's what the laboratories had, you'd have to have the new material and the old material coming in at kind of a slope across here. So that maybe on one side of the line you'd have old material, on the other side you'd have new material. You can see what one of the problems here would be. because, we don't know how it was sampled, and we have no control over that now. And they'd probably be just as likely to take vertical cuts as horizontal cuts in doing the subsampling. Now, if you take a vertical cut, yeah, you get a mixture of old and new material. Now, there's 16 different samples. Okay? So out of that, you're going to have 8 samples that ought to date to either old or new material, either 34 AD, 30 or 34 AD, or 1550, whatever. Yet that's not the case in the measured values. None of them date to 34 AD, none of them date to 1550. They all date consistent with this range of data. So that my nuclear analysis computer calculation, this is the entire shroud. Right down here, I'm normalizing the analysis to 1660. But you come up to the knee, and you can see what it is here. This is 1900 AD, 4300 AD, 4800 AD, 2300 AD. On the other side, away from the wall, because it makes a difference. Next to the wall, you get more neutrons reflected back from the limestone, so it goes through the cloth again, producing additional carbon-14. So this left side is away from the wall in the way that I modeled it. Now, maybe his head was facing to the left rather than right, so everything would then just be reversed. No big deal. But you notice on this side then, we have 1800, 3700, 3100, and 1500, so that there'd be a range of dates. The value of 8500 would be on the back side, right about there, under the center of the body mass. So this is the neutron absorption hypothesis. Okay, what do we have here? Oh, this is how my predicted values from the previous table compare with Damon. Fairly good agreement. So the 4 things that we know about dating, 1260 on the date, the slope, the range, and the sudarium. My evaluation here is this in comparison. Which explanation is best? We only have 2 that are being considered now, really. There's the invisible reweave, or there's neutron absorption. So the way that I analyze it, here's the reweave, here's the neutron absorption. The date, yes, either hypothesis can explain the date. What about the slope? Yes, either explanation can explain the slope. The range, well, certainly neutron absorption can explain the range, but the reweave is very unlikely. You'd have to assume that in all 16 measurements, they cut it vertically in order to get both the old and the new material. And the reweave doesn't explain the sudarium at all, because that's a different piece of cloth entirely. Whereas the sudarium date of 700 AD is very consistent with the neutron absorption. That's it. Oh, let's see. So the big question here that's always asking me is, where did the neutrons come from? There's 2 options: from the body or from the process that caused the disappearance of the body. What happened to the body? It did not disintegrate in a nuclear disintegration. No, it made a transition into an alternate dimensionality. Go to my website, Shroud, research.net, and go to my research page to see the paper on that topic. See my little article on Mr. Dotman in Lineland to understand what I mean by a transition into an alternate dimensionality. And the best word, I think, is it occurred in a singularity. We'll talk about that later. Additional work to do. Use better model for the body, get greater detail in the calculations, effective location on the sample, neutron absorption in limestone, transport across the air and the shroud, and how that changes with dimensions and with resolution, and the nature of the image resolution as a result of radiation going through the remaining part of the body. And I'm done. Oh, questions? We have questions over here?
I'm going to be setting up. You got
Yes.
a minute, because I'm going to have to set up a different...
Yes, okay. Go ahead.
Just a simple question. It's a beautiful hypothesis.